Saxon Algebra 1/2, lesson 115. Today, we're going to talk about polygons. Oh yeah, it's a geometry topic that we're going to come back to again and again because it's a basic foundational set of ideas. Polygons are shapes with straight sides, okay? There's nothing curved. And they are closed. And what I mean by that is that something like that is not a polygon. See, it's not closed, it's open-sided. It can have what we call a cave. Caves are okay. A cave would be something that looked like this. There, pretend that other line isn't there. This is a cave, okay? And the idea is that you can take 2 points anywhere inside the polygon and you can connect them, and it's okay if it goes across an opening called a cave. Now, this is a lesson that's super useful if you have your book handy, because there are a lot of tables and charts in the lesson that we don't want to take the time to copy. So if your book is handy, grab it. If your book is not handy, write down this page number because you're going to want to remember it and use it during the homework. Page number is 358, right up there. So here are some examples of are they or aren't they polygons. The first one is not a polygon. Can you guess why? It's rounded. No bueno, it's not a polygon if it's got that. This is not a polygon. Look, the answers are all right there. This one's not closed, is it? There's a gap right there. This one's okay. This is a concave polygon. There's a cave in it, it's fine. And this is a convex polygon, which just means a basic polygon. And they're showing the thing again where you can make dots anywhere within the polygon and connect them. So here are some do's and don'ts. Down here is some important information. Polygons have names depending on how many sides they have. Some of the simpler ones you'll remember. 3 sides are triangles. Oh, okay, that's not very hard. 4 sides are quadrilaterals. That includes squares and triangles. 5 sides is a pentagon. 6 side is a hexagon. Those most people can use conversationally. Once you get up into 7 sides or more, it gets kind of weird. And I don't expect you to necessarily remember that. Octagon maybe, because that is the shape of the stop sign. In not just the US, but many countries have an 8-sided traffic sign that means stop. So this is good to know. And then here's an example of a polygon that has each of its vertices, which is the plural of the vertex, which is where the 2 sides come together. We typically use uppercase letters to label those. And then when we're talking about them, we often list them all. So John just goes totally nuts in this lesson. And look, he shows 16 different ways that you could list those letters in order depending on where you start. Don't hurt yourself thinking about this. It's just I'm gonna say it. It's a ridiculous exercise. John goes totally off the deep end here in just showing all the different ways you could label those. Don't worry about that. That's crazy. This is interesting. Regular and irregular polygons. Now, what's the difference between these 2 triangles? This one's just kind of wonky and weird. The angles are different. The side lengths are different. This one is perfect and even. Each one of the angles is 60 degrees. 60 times 3 is 180. We know that all triangles have to add up to 80 degrees on the inside. And then these little lines, these little tick marks, those mean, same length. So that means that all these sides are the same. We're going to spend a lot more time looking at what we're calling regular polygons rather than these irregulars. So whenever you hear or read that we're dealing with a regular quote-unquote polygon, say yay. That means it's easier. Here's a great example with quadrilaterals, with four-sided. This is an irregular, this is a regular. This looks much easier to deal with, doesn't it? And then we can do the same for pentagons. And look, even a hexagon. This is a six-sided shape. It's technically a hexagon, but that one's much easier to deal with. All right. So regulars are where it's at. Now, this is called a different part of the triangle. We've got the sides. We've got the vertices. Vertex, the plural is vertices. Vertex means a corner, is how I always think of it. It's where two sides meet. That's called a vertex. That's where we often put the letters. We can go kitty corner, and those are called diagonals. And we'll talk more about those as we go. They're very useful. So we could draw diagonals here from A to C, and then from X to Y. All right. Different kinds of quadrilaterals. So all of these have four sides, but they're quite different. Let's start with the neatest, cleanest square. Look how cute and perfect. Oh, if every quadrilateral could be a square, how easy our lives would be. But they're not. Sometimes we stretch out one pair of sides and we make it into a rectangle. Okay. That's not too much more complicated, but those are the only two that are straight and even, okay? Then we have to deal with some of these squished shapes, all right? So I think this is the simplest to understand. This is close behind it. Now, if you were ever a little kid, spoilers, I know you were, and I was too, and whenever we got something in a relatively big box, we loved to play in the boxes. I'm sure you did too. Very often what we would do is open up the bottom of the box, open up the top of the box, make a tunnel so that you could crawl through it. And it would usually look like either this or this when we started. But after 5 minutes of horsing around, I had 3 brothers, and you know what? It always turned into some sort of slugfest. Our boxes would all get tipped kittywampus like this. And so that's how I remember the rhombus and the parallelogram, is they are boxes that my brothers have been roughhousing in, and they're crooked now. They're not perfect. So a perfectly square box turns into a rhombus, and a perfect rectangular box turns into a parallelogram. It's just the squished version after someone has been knocking it about. A trapezoid is a little bit different. It has a top and a bottom that are parallel but not the same length. So these two other sides are not the same, right? This is not a box shape. All of these could be boxes. These are the perfect ones. These are the squished ones. This is something else. A trapezoid is a weirdo. All right? Okay, let's see what else John has for us. Oh, I think we're near the end to this. I'll write these words down, but I want to show you these pictures too. Congruent is a word in geometry that means equal. We don't say equal when we're talking about shapes. We say that they are congruent. They have the same sides and they have the same angles. They're exactly the same. Now, sometimes we can take a shape and create a congruent shape and use a word to describe how we changed it. This is called translation. It just means we're taking the shape, we're just sliding it around, right? We're not changing the shape itself. We're just pushing it around to different places. That's called translation. We slide it, but we don't rotate it, okay? Rotation is a different animal, and I'm going to write these 3 down in just a minute. Rotation's a different animal. I always think of these as pinwheels. It's like if you put a pin up at the top and then you push the bottom flat side around. That is what a rotation is like. Okay, it's actually spinning around. A reflection is when the shape looks in the mirror and sees itself, right? And we can sort of imagine it like this, right? You get a mirror image of it. The other way I think of reflection is that you take, here I'll do it with this pad of paper that I have. Here's a list that I was making for a photo album I'm working on. If I am reflecting this pad of paper, I'm turning it over, okay? These are kind of like little see-through triangles, so mine looks quite different when I turn it over, right? These guys are see-through and they don't look that different, but we're picking it up and we're turning it over. All right, so let me just show you in the practice. you are trying to give as many names to each one of these shapes as you can. You're using as many of these words to describe. Use these notes in the book when you work on these practice problems. And then down here, you're looking at two of them and saying, did you change it by translation, rotation, or reflection? Okay, and then the same thing is happening here with the rest of these exercises, all right? This is one of these concepts that isn't that hard, but I think the problems that John devises make it more confusing than it would be in the first place. So if your brain's going a little wonky, then this is what I recommend you do. Look at the answers, see what they are, and then see if you can make sense of that. Okay, I just want to write down a few more of these. Remember, you write down everything I write down. Congruent means equal. Okay, we never say in geometry that things are equal. We say that they are congruent. It's just the way life is. All right, and then we can move congruent shapes by translation. That's one way we can do it. And that is where we slide, but don't spin. And then we have rotation, which is the one that's kind of like a pinwheel. And we're allowed to spin it. And then the last one is reflection. And that's where you can think of it as the mirror image. Or the other way that sometimes help is to pick it up and turn it over. Again, in that second part of the practice problems, you're going to be asked to tell which ones of these you would have to use. And some of them are combinations of multiple of these in order to get from the first shape to the second shape. They're all labeled A and B. So to get from shape A to shape B, what would you have to do? Slide it, spin it, or pick it up and turn it over. So that will be your challenge. All right, this is a basic introduction to polygons. I know you've heard some of this in the past. You knew what a triangle was a long, long time ago. We're going to build on this. Every year, we're just going to keep coming back to it. We're going to learn how to write equations to show how to change shapes like this. We're going to get much more sophisticated in our knowledge, but that's enough for today. All right, thank you very much. I will see you next time. Goodbye.